All right, we're going to get into some addition rule and multiplication rule. We're in section 4.2. We're going to be looking at addition rule, which is for finding the probability of this or that. And we're going to be looking at the multiplication rule when we're trying to find the probability of this and that. So we'll be doing addition rule and multiplication rule. And both of these are compound events, which happen when we're combining two or more simple events. So let's start with the addition rule, or. It's the probability of A or B is equal to the actual probability. So we calculate the probability of A or B by adding them together. However, what can happen if you do this or that is there can be an overlap. And we always want to make sure we don't count things twice. So we subtract an overlap if they have one. And there's a specific word for overlap, and that is a disjoint event does not overlap. And disjoint events mean there's nothing to subtract, there's no overlap. If it's not disjoint, that means it does happen at the same time. It can happen at both of them, and therefore we do have to subtract. So let's just do a couple of vocabulary examples here. Explain why the two events are disjoint. So they're telling us already that they're disjoint, and disjoint means no overlap. So let's look here. Randomly selecting a male and randomly selecting a female. Can you have someone who is both male and female at the same time? No. So these are disjoint because you cannot be both male and female at the same time. You can't select someone who's both male and female. Now, these are not disjoint. Randomly selecting someone taking a statistics course and randomly selecting someone who's female, there is overlap here because someone can be both in stats and female. And so that kind of gives you an example of not disjoint and disjoint. Let's look at another example. Is determining the probability of selecting a positive test or uses drugs, someone who uses drugs, disjoint or not disjoint? So basically the question is, can they happen at the same time? So is there any overlap? Can someone be positive? So we're looking at the positive. And someone using drugs? And the answer is yes, they can happen at the same time. So these are not disjoint. There is overlap. We would have to subtract any overlap when we calculate, if we were to calculate that. Go ahead and answer this problem here and then press play when you're ready to see the solution. And there we go. So to apply the addition rule, first we have to make sure, okay, we see the word or, we think addition. And then we determine if the events can happen at the same time or if they're disjoint. And if they're not disjoint, then we need to subtract the overlap. We need to calculate the probability of the overlap. But if they are disjoint, good news, there's nothing to subtract. Okay. We're going to find three probabilities associated with this table by using the long rule. Some of these are going to be obvious because we see the table, but we're going to calculate them all out. Find the probability of selecting a subject who had a positive test or uses drugs. Okay, so let's start by writing positive test or uses drugs. So the first question is, can these happen at the same time? Are they disjoint or no? These are not disjoint. So we're going to have overlap here. Overlap, not disjoint. We're going to have to subtract. So what that means is we kind of just like split this up. So we've got the probability of someone being positive plus the probability of someone using drugs minus the probability that someone is positive and uses drugs. So remember that always the denominators are our totals. So if we were to add up that whole table, we would get 555. So those numbers don't change in the addition rule. So how many positive people do we have? So we've got to add those two numbers up and we get 70. How many people that use, that's in this direction, that's 50. And how many people are positive and use, that's 45. And so when we calculate this number, we get 75 over 555, we get 0.1, and I cannot read my handwriting if that says 0.13 or 0.135 or 0.125, but I think it says 35. All right, so we're doing this two more times. So find the probability of selecting a subject who had a positive test or a negative test. So probability of a positive or a negative. Can these happen at the same time? Can you get both a positive or a negative at the same time? No, these are disjoint. So there's nothing to subtract here. So it's the probability of a positive plus the probability of a negative. Remember that our total isn't changing here. How many positives do we have? I believe that was 70 last time. And how many negatives? That would be 485. You guys might have an idea here based on last section. If we get 555 over 555, we get 1. It's certain you're either testing positive or negative. All right, this last one here. Find the probability of selecting a subject who had a negative test result or does not use drugs. So we've got probability of someone who is negative or does not use. So first we need to find out, can there be overlap? Can someone be negative and not use? Yeah. So these are not disjoint. There is overlap. So we've got to do the probability of a negative plus the probability of does not use minus the probability of they're negative and they don't use. And we know that the totals are 555. So probability of a negative, these are our negatives, 485. People who don't use are down here. So that's 505. And the people that are negative, that have a negative result and don't use, is 480. And so when we calculate that, we get 510 over 555. We get 0.919, which makes sense that they're getting a negative and not using. But there are those false positives. All right, you try these 3. And I'm going to show you the solutions one at a time. So for the first one, second one, and third one. Now, we started talking about complementary events previously, but when we want to figure out something that's not A, we actually know that the probability of A or not A is certain. It's either this or that. So we can actually say that if we want to calculate something that's not A, we can subtract 1 from the probability of it occurring, or vice versa. So based on a journal article, the probability of randomly selecting someone who has sleepwalked is 0.292. If a person is randomly selected, find the probability of someone who has not sleepwalked. So we know that we want to know the not, right? So that's 1 minus the probability of it occurring. So that's 1 minus the probability of it occurring. So that would be 0.708. 708. Give these few a try. And there you go. And we're going to stop there. So that section or part 2 covers the multiplication rule.